Hello. Okay. Now enough of the waiting. Okay. Let's start the section. Okay. Enough of waiting. So today we are going to discuss the lecture 10 of the live discussion section. Okay. In this section we will discuss lecture 46 to lecture 50 by Professor Ashok Desai, IIT Kanpur, of the subject Introduction to Airbreathing and Propulsion by NPTEL. Okay. In this section, first we will see some of the theoretical problems, theoretical questions, and then we will go through two problems, okay, at the end, related to this lecture. Just 1 second. Okay, the question is, the type of rotary compressor used in aeroplanes is of dash. Okay. Okay. So the type of rotary compressor, basically the rotary compressors are of two types. So the type of rotary compressor used in the airplanes is of dash type. Okay, basically two types of rotary compressors are there. One is the centrifugal and one is the axial type. So for the rotary compressor used in the airplanes is axial type. Okay. Just let's go to the next one. So gas turbine use the following types of air compressors. Okay. Same, because in the so basically in the rotary compressor in the aeroplanes, gas turbine engines are installed. Okay. So it's actually they just twisted the question. So the gas turbine also uses the axial flow compressor. Okay. The axial flow compressor is preferred in aircraft gas turbine because of what? Okay. Okay. So, so here aircraft it means what? So aircraft means it can be fighter aircraft or commercial aircraft or cargo aircraft. Okay. So okay. So okay. So in all these types of aircrafts, axial axial flow compressors are used. Okay. Okay. Because the of what? Low frontal area. Okay. Because of low frontal area, the axial flow compressors are used in the fighter aircraft, commercial aircraft, or cargo aircrafts. In axial flow compressor, the exit flow angle deviation from the blade angle is a function of dash. Okay. So always remember the blade angle is always a function of blade camber and incidence angle. Okay. So the answer is B. An axial compressor gives optimum performance at a dash. An axial compressor gives optimum performance at high speed and large volume flows. Okay. Okay. So an axial compressor gives optimum performance at what? High speed and large volume flows. In axial flow compressor, the flow of air is dash to axial compressor. Okay. Because the name suggests everything, axial means it's parallel. Okay. So in axial flow compressor, the flow of air is parallel to the axial compressor. If the flow of air through the compressor is parallel to the axis, then the compressor is called what? Axial flow compressor. Okay. Okay. In the different way, the same question can be asked. Okay. In the terms of flow of air or in the terms of what? To the parallel to the axis or all these things. Okay. So the airflow is parallel to its axis. Um, The degree of reaction in an axial flow compressor is defined as the ratio of static enthalpy rise in the dash. Okay. Okay. So first of all, write down what is the formula of degree of reaction. Okay. So the formula of degree of reaction BOR degree of reaction is equal to delta H rotor divided by delta H stage. ठीक है. So if we can see, it's the delta H of rotor to the delta. So only the option C actually satisfy this. Okay. Rotor to the static enthalpy rise in the stage. Okay. Okay. In an axial flow compressor, the ratio of pressure in the rotor blades to the pressure rise in the compressor in one stage is known as what? Okay, so this is basically the definition is basically tells us about the degree of reaction, okay, or the DOR. Okay. See the same relation delta H rotated by delta stage. Here also delta P rotated by delta P stage. Okay. In terms of enthalpy and in terms of pressure, the formula remains the same. Okay. So DOR. So DOR is equal to delta P rotor divided by delta P stage. Okay. The mass flow rate of air compressed in axial flow compressor is dash centrifugal compressor. Okay. So okay. So m dot relation we just for the axial flow and centrifugal flow compressor is m dot of axial flow compressor is greater than m dot of centrifugal flow compressor. Okay. So the answer is what? The mass flow rate of air compressed air axial flow sorry the mass flow rate of the air compressed in an axial flow compressor is greater than that of the centrifugal compressor or the higher than that of the centrifugal compressor. The answer is B. So yes, the degree of reaction is usually kept dash for all types of axial flow compressor. Okay. Okay. So always DOR is always 0.5. The half of the 50% value always taken for a general operation in a axial flow compressor. Okay. That means equal effect of both rotor blade and the stage. Okay. Axial flow compressor has the following advantage over centrifugal compressor. Okay, what are those advantages? Okay, so the axial flow compressor having larger air handling ability per unit frontal area. Okay, so this is what the advantage of a axial flow compressor over the centrifugal compressor. Okay. Okay, so the air handling per unit frontal area is great for the axial flow compressor. Axial flow compressor is greater than the air handling by frontal area for the centrifugal compressor. Okay. So answer is A. Hmm. Okay. Let's go to the next one. So now let's start the problem. Okay. So yeah, wait. Okay, so read the question and try to solve. Hope you tried the question. Let's start solving. So the question is, an axial flow compressor was tested and found that it gave a pressure ratio of 3 atmosphere and a temperature rise of 125 degree Celsius. A 200 kilowatt motor was used to drive the compressor. Determine the compressor efficiency and mass flow of air delivered. If the mechanical efficiency is 95% and pressure and temperature at the inlet were 1 atmospheric pressure and 300 Kelvin. Yeah. Let's start solving. So the P2 by P1 is equal to 3. T2 minus T1 is equal to 125 degrees Celsius and T2 is equal to 125 plus 300, okay, is equal to T2 equal to what? 425, okay, 425 Kelvin, okay. So let's draw the TS diagram for process 1 to 2. Okay. This is 1, this is your 2 dash, this is 2. Okay. This is T1, the T1, T2 dash and T2. Okay. So let's consider process 1 to 2 dash. Okay. For process 1 to 2 dash, so T2 dash by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. ठीक है. So what is T2 dash then? So T2 dash is equal to 300 into 3 to the power 0.4 by 1.4. So if you solve it, you will find T2 dash as 410.62 Kelvin. Efficiency of the isentropic efficiency of the compressor is T2 dash minus T1 divided by T2 minus T1 is equal to 410.62 minus 300 by 425 minus 300. Okay. This is equal to 0.885 or 88.5 percentage. Okay, so let's apply the power conversion equation. So MA Cp delta T, m dot A Cp delta T is equal to inlet pressure into mechanical efficiency. Okay, so we need to find out the m dot A. Okay, so let's substitute all the values. M dot A into 1.005 kilojoule per kg Kelvin into 125 Kelvin is your delta T is equal to inlet pressure is 2000. In the question it's given the inlet pressure is 2000 kilowatt. Okay, so 2000 kilowatt motor is given. So 2000 kilowatt is your power. Sorry, not pressure, power. 2000 kilowatt power is there into mechanical efficiency also given in the question. Mechanical efficiency is 95%. Okay, so 95% efficiency also there. Okay, so if you solve, you will find m dot A as 10.124 kg per second. Okay. Okay. Okay, let's come to the next question. Read the question and try to solve. Okay, so I think you tried the question. Let's start solving. Okay, so the question is a pressure ratio of 1.5 is to be achieved in a single stage and of an axial flow compressor. The approach is the rotor at an absolute velocity of 200 meter per second at an angle of 12 degree. The speed of the compressor is 8000 rpm and has a mean radius of 30 centimeter. Determine the blade angles and blade height if the mass flow is 10 kg per second. Okay. The stagnation pressure is 1 bar, stagnation temperature is 300 Kelvin, compressor stage efficiency is 95%. Okay. So for this type of question, always draw the velocity triangle. Okay. Velocity triangle at the inlet and the velocity triangle at the exit. Okay. 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 So this is your VRW1. This is your VW1. Okay. Totally U. Don't go to hell. This is your V1. V1 is equal to 200 meter per second. This is 12 degree. This is BF. This is beta 1. Sorry, this is VR1. This is beta 1. Okay. So this is your inlet velocity triangle. Okay. Okay. This is your inlet velocity triangle. Okay. So let's write down what are the things given and we just need to solve accordingly. Okay. So let's find out the blade speed. Okay. The blade speed U is equal to pi dn by 60. Pi 0.6 into 8000. Okay. Divided by 60. Okay. So if you solve it, you will get the U value as 251.2 meter per second. This is your U value. Okay. So let's apply the trigonometric relation for the angle 12 degree. Okay. So what is sine 12? Sine 12 is equal to VW1 by. So sine 12 is here what? The opposite side divided by the diagonal. Okay. VW1 by V1. Okay. So we know already V1 value. Okay, the absolute velocity of the rotor given 200 meter per second. Okay, in the question it's mentioned the absolute velocity of the rotor is 200 meter per second. Okay, okay, the air approaches the rotor at an absolute velocity of 200 meter per second. Okay, so V1 already given as 200 meter per second. Let's find out the VW1 from this. Okay, so VW1 is equal to 200 into sine 12 implies VW1 is equal to, if you solve it, you will get 41.58 meter per second. Okay, this is your VW1. Okay, so let's find out VRW1. VRW1 is equal to, if you see, VRW1 is equal to U minus VW1. Okay, is equal to U minus VW1 is equal to 251.2 minus 41.58. So VRW1 is equal to 209.62 meter per second. Okay, so let's find out the VF. So VF will be what? VF will be, we can find out from the cos 12. So VF is equal to V1 into cos 12. Okay, because cos 12 is equal to VF by V1. Okay, so VF is equal to V1 into cos 12, 200 into cos 12. So BF is equal to 195.63 meter per second. Okay, so let's find out the tan beta 1, or we need to find out the angle beta 1, because we already have the BF and we already know the VRW1. So tan beta 1 is your VRW1 divided by BF. Okay, tan beta 1 is your VRW1 divided by what? BF. Okay, tan beta 1 is equal to VRW1 divided by BF is equal to 209.62 divided by 195.63. Okay, beta 1 is equal to 47 degree inlet blade angle. Okay, okay, so just find out the beta 1. So next we need to find out the T1. So T1 is equal to T01 minus V square by 2CP, which is 300 minus 200 square by 2 into 1005. Okay, so if you solve it, you will get T1 as 280.1 Kelvin. Okay, so yes, so next we need to find out the delta T. Delta T is equal to T2 minus T1 is equal to, just apply the isentropic relation. Okay, and in the question the pressure ratio also given as 1.5. Okay, the pressure ratio given as 1.5. Just apply the process 1 to 2, just apply the isentropic relation between the temperature and pressure. So which gives to T1 into Rp to the power gamma minus 1 by gamma minus 1 is equal to 280.1 1.5 to the power 0.4 by 1.4 minus 1. So delta T is your 34.4 Kelvin. Okay. So next we need to find out the VW. Okay. So just use the the mechanical efficiency into Cp delta T is equal to U into VW2 minus VW1. Okay. By applying this relation, we can calculate the VW2. The VW2 is equal to VW1 plus Cp delta T divided by U into mechanical efficiency. Just substitute the value. VW2 is equal to 41.58 plus 1005 into 34.4 divided by 251.2 into 0.95. Okay. So VW2 is equal to 172.326 meter per second. Okay. So okay, now let's go for the exit part. Okay. So now let's draw the exit velocity triangle. Okay. For exit, we represent all terms in terms of 2. Okay. Okay. So yes, this is your beta 2, BF, B2, alpha 2, okay, BR2, BR, W2, BW2. So since we have the value of okay, so VW2 we already know. Can we calculate VRW2? Yes, because U is fixed, so you can calculate the VRW. Okay. So it is so VRW2 is equal to U minus BW is equal to U already we know from the inlet triangle 251.2, BW2 is 172.326. So what is VRW2? VRW2 is equal to 78.87 meter per second. So what is tan beta 2? So tan beta 2 is equal to, because VRW2 we know, VF already we know, so just let's calculate the angle beta 2. Okay, so VRW2 divided by VF is equal to 78.87 divided by 195.63. Beta 2 is equal to 21.96 degree. Okay, so this is your exit blade angle. Okay, and this is your answer. So what is the pressure at inlet? So the pressure at inlet. Okay, so P1 we need to calculate. Okay, so T01 by P01 so P1 is equal to what? 0.78645 bar. Okay. Okay. This is your P1. Okay. So we already know the RP is the pressure ratio, which is P2 by P1. We already know the value. So RP is equal to P2 by P1 is equal to 1.5. So P2 is equal to 1.18 bar. Okay. If you take and substitute the P1 value from here, we can calculate P2 as 1.18 bar. Okay. Okay. Now what is T2? Your T2 is equal to okay. Okay. So T2 is equal to 34.4 plus 280.1. So T2 is equal to 314.5 Kelvin. Okay. So what is rho 2? Rho 2 is equal to P2 divided by RT2 is equal to 1.18 into 10 to the power 5 divided by 287 into 314.5. Rho 2 is equal to 1.3 kg per meter cube. So what is m dot? M dot is equal to rho 2 into pi by 4 d2 square minus d1 square. Okay, so we know all the values, just substitute. 10 is equal to 1.3 into pi by 4 into d2 square minus d1 square into 195.63. Okay, so we can write down it as d2 plus d1 by 2 into d2 minus d1 by 2 is equal to what? 0.01245. Okay, so dm into d2 minus d1 by is equal to 0.01245. Okay. In the question it's actually given dm value. So in the question the mean radius given as 30 centimeter. Okay, what does it mean? That means rm is given as 30 centimeter, which is equal to 0.3 meter. So dm will be your 60 centimeter, which is 0.6 meter. Okay. Yes, so 2 into 30 by 100 is equal to 0.6. Okay, so yes, so yes, so now the d2 minus d1 will be d2 minus d2 by 2 minus d1 by 2 is equal to 0.02075, so which is equal to r2 minus r1. Okay, is equal to height of blade is equal to 0.02075 meter. Okay. Is equal to 20.75 mm. Okay. Okay, so this is the blade height. Okay, this is the answer, and all the blade angles we already found out. Okay, the beta 1, beta 2, everything. Okay, we already find out alpha 1, alpha 2, all blade angles we already find out. Okay. So thank you very much for attending the section. If you are attending the recorded one also, thank you very much. If you have any doubts, you can ask in my comment section of my channel. My channel name is Sumit Sagar Hota. Okay, feel free to ask the questions. We'll see next week 6 to 8 p.m. Saturday. See you. Good night and have a nice day.